So in this video I'm gonna derive the circuit response, uh, the LC circuit response for sinusoidal input in frequency domain. So let's get started. We're gonna use this circuit for KVL, and if necessary we'll use this KCL circuit, but the my main focus will be this, the KVL circuit. So in frequency domain, what we can see that LTI system which generates linear differential equation with constant coefficient after Laplace transform, now it will generate a, an algebraic equation after we apply KVL or KCL. So by KVL we're gonna get an algebraic equation. So SL plus 1 by SC IS minus LIO plus VO by S equals Vs omega by S square plus omega square. Um, we are now in this situation. Now S square LC plus 1 IS equals, so if we take this SC in the right hand side, so Vs omega SC by S square plus omega square plus SLC IO minus VO by SC. So cut out. So now we are gonna, so here IS is say VSC omega S by S squared plus omega squared into S squared plus S squared LC plus 1 plus SLC initial current by S squared LC plus 1 minus VO by S squared LC plus 1 C. So this is the situation here. So we already know what the answer for this two term will be. We are only gonna focus in this sinusoidal part, or let us focus on this part only. So I'm focusing on this part only. So VSC omega C by, sorry, omega S. So VSC omega S squared plus omega squared S squared LC plus 1. So what we're gonna do here is we're gonna break this in partial fraction. So VSC AS plus B by S squared plus omega squared plus DS plus E. We are not using, this is for our convenience, okay, DS plus E. So S square LC plus 1. So say Here, if we to find the constants, arbitrary constants, say omega s is a s plus b into s square lc plus 1 plus ds plus e s square plus omega square. Omega is the input frequency. So now if we just multiply these two terms, so a by, so say lc is omega n square, 1 by omega n square, so omega n squared is cube plus as plus b by omega n square is square b plus d s cube plus d omega square s plus e s squared plus e omega squared. Now if we equate the coefficients of, so equating, so if we equate the coefficients of s cube, s square and s, we will find that a by omega n square plus d equals 0 and a a plus d omega square is omega. Coefficient of s cube, so a by omega n square plus d, it will be equal to 0 and a plus d omega square is omega. So this is the coefficient, these two is the coefficient of s, which is omega. So from this we can find, so here a is minus d omega n square, which will give us d equals omega by, so here we found our answer. So d is omega by omega square minus omega n square, and a is omega n square by omega square minus omega n square. Coefficients of s square, it will give us b by omega n square plus e equals 0, and the constant e b plus e omega square is 0. So here both b equals 0 and e equals 0. So we have found our constants. These are omega c, so a is omega n square by omega square minus omega n square plus 0, b is 0, s square plus omega square plus d is omega s by omega squared minus omega n squared plus 0 by s squared LC plus 1. So if we take the common omega square minus omega n square out, so it will be VSC by omega squared minus omega n squared. So here we find there is an s obviously. So omega n squared, so this will leave us with s by s squared plus omega squared plus here s by, if we just take this, so we have here if we take the LC common, it will give us omega n square. So we have already taken the omega n square common as common, so s square plus omega n square. So this is the final situation. So the current response, sorry, current response is VSC omega n squared by omega squared minus omega n squared s by s squared plus omega squared plus s by s squared plus omega n squared with the initial the other two parts, so SLC IO by s square LC plus 1 minus VOC by s square LC plus 1. So we are gonna use the Laplace, inverse Laplace. So inverse Laplace of IS will give us IT in time domain. So from frequency domain to time domain, so VSC omega n squared by omega square minus omega n squared. So inverse Laplace of this is cos omega t plus this is cos omega nt, and if we pay close attention, it will, this is io cos omega nt, and this is minus vo by omega nl sine omega nt. So let me write this a little bit clean, minus vo by omega nl sine omega nt. So if we just do something about this, so here vs omega n square is 1 by lc, so vs omega by l omega square minus 1 by lc cos omega t plus cos omega nt plus dot 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 and if we just rearrange this, it will give us the same. Omega L minus 1 by omega c, and cos omega t plus cos omega nt plus dot dot dot. Thus we found our final answer. So z cos omega t plus cos omega nt. So omega L minus 1 by omega c is the magnitude, the impedance, the magnitude of the impedance. Now io cos omega nt minus vo by omega nl sin omega nt. So it, the complete response in frequency domain. So if we just rearrange this, plus vs by impedance cos omega nt minus vo by omega nl sin omega nt plus vs by z cos omega t. So this is the current response we got from the frequency domain analysis, where z is the impedance. So if you wanna, this is basically the answer. So I hope you understood my explanation. I think there is some plus minus difference from the time domain analysis. You can see if you can see it yourself, you can derive the equation yourselves. If you find the um, any mistakes I have made in my explanation, you can tell me. And um, please, if you like my explanation, like my video and subscribe to my channel, and thank you.